Hey team, it's Mr. Z, and today we're going to go ahead and look at multiplying fractions. And essentially what we're going to be doing is we're going to look at that advanced factoring technique that I preluded last time. So let's go ahead and dive on in. All right, so it said cross reduce if possible, multiply straight across, and simplify. So essentially what I'm going to show you is that in this example is essentially an advanced technique. This person displays the ability to look at numbers as a combination of parts. When I look at this problem, so I'm looking at 4/6 times 3/10. But this person is going to go ahead and see it in small pieces. They're going to say 2 times 2 is 4. Now, this is actually contrary. Usually we do the opposite. We simplify. We usually don't break things down. But this is an equivalent expression. I'm going to do the same thing. And what is revealed is that I can actually do some simplification beforehand rather than later. So let's going to keep on going, and I'm going to multiply 3. Well, 3 is 3 times 1, and 10 is 2 times 5. So essentially what we're doing is we're looking at numbers and breaking them down. Now, some of you might know what happens next. We're going to go ahead and represent this as one giant fraction. Remember, multiplying fractions is just going to be multiplying the numerator and the numerator, and then we're going to multiply that group by 3 times 1. Remember, grouping symbols such as parentheses indicate multiplication. Notice where these numbers are coming from. All I did is rewrote it as an equivalent expression. Now, I'm going to do the same thing. The first group times 2 times 5. Okay, so again, right now it looks like a jumbled mess, and it's like, well, wait, where am I going with this? So the idea is that we're multiplying all of the parts and rewriting it as a single fraction. Now, this is where a handy tip of expertise comes in. I'm going to think of it now as 1. I'm going to just reorganize it in order. 2 times 2 times 3. Instead of multiplying it out, I'm going to do the same thing for the denominator. Now, I have an organized fraction that, again, is equivalent. I haven't broken any rules. I've taken a fraction and broke each numerator down to its most basic of points. Now, I'm going to go ahead and use a fact. 2 divided by 2 is 1. 3 divided by 3 is 1. 1 divided by 1 is 1. 4 divided by 4 is 1. If I had a negative number, negative 2 divided by negative 2 is 1. So I could even do a decimal. 0.5 divided by 0.5 is 1. I could even have a fraction divided by another fraction and have it be 1. Moral of the story is when I cross this out, what I'm going to indicate is that it's going to be multiplied by a 1. A 1. A 1. Notice how this problem turns into 1 over 5 quite quickly. What is the numerator? What is 1 times 1 times 1 times 1? And what's left?